welcome back to your MATLAB mentor, where MATLAB turns math into motion. Let's go to smarter, not harder. Opening up a new episode. Today, we will continuing our talking about plotting. Please make sure that you have been watched all the previous episodes as they are all depend on each other. And I'm seriously one of the last 2 or 3 episodes because they were all about plotting, and today we're gonna continue our talking also about plotting because this is one of the most powerful features of MATLAB. So today we're gonna talking about scatter plot. Scatter plot, I would say this is healthy plot. Okay, so let's begin. First, write our comments and everything. Scatter plot. The healthy plot. Okay, this is a good way to always remember scatter plot. But why I said it's a healthy plot? Because it's healthy, because the only thing he cares about after x and y axis is the sizes. So scatter plot, when we are doing, and you guys gonna see it in actually when we start coding, it's gonna be x axis, y axis, and then the sizes. Because the thing about a scatter like function or plot in general is perfect for showing how each data point behaves individually without connecting lines. So like it's gonna be just the circles without any lines, and this is how it's gonna be represented. Okay, so this is just a small introduction about scatter plot, and let's begin. So at any plot we have to specify x and y axis. So let's start with x axis. Same thing, line space. Hopefully you guys by now like pretty familiar with line space as we used it several times in our episode so far. So 0 to 3 by 200. Okay, what this means, like quick recap, it just mean it's gonna start at 0, end in 3 pi, which is 9.42, and has 200 evenly spaced point in between. So between 0 and 3 pi, gonna has 200 evenly spaced point on the x-axis, and this is x. So 200 evenly spaced points between 0 and 3 pi. Okay, now let's go to x-axis sister, which is y-axis. Cosine x plus rand 1 to 100. I want to mention one more time that all the example is pretty much based on like MATLAB documentation, and also I do mention this because in many exam, when you guys have any exams about MATLAB or like practical all this stuff, you guys are allowed to use MATLAB documentation. So when MATLAB documentation become your source, this will be super helpful like along your way in learning. So you can always like refer back to MATLAB documentation, and you can always like see different tips and tricks and advices, even examples. And we showed in episode 1 how we can find help in MATLAB. Okay, returning back. So now cosine x plus rand 1 to 200. Okay, so rand, we explained this in our first episodes, mean like gives me random number. Okay, but what's the point of like cosine x plus rand 1 to 200? Random number, okay, rand means like random number between 0 and 1 in a matrix of 1 row, 200 column, this random number. Okay, but again, what's the point? Why this line has been written in this way? So it's just cosine x, okay, it simulate oscillating. So like, let's write here cosine x, it's oscillating wave, okay, and rand 1 to 200, it's just a noise has been added to this wave. So that's why it got represent random number between 0 and 1, okay, in a matrix like 1 row 200 column, all of this noise to the actual stable oscillating wave, which is cosine x. So here it just noise. This I wanna another comment here, because this simulates real world sensor data, maybe like sensor management and experiment. However works in engineering and in sectors that has radio waves, there is always noise. There is always like a lot of measure, a lot of tools like that do measure for accuracy or for clarity. Same in MATLAB. MATLAB, when you do represent some data, a lot of data has been affected of noise in different ways, and this is we try to simulate the code to be like cosine x, which is oscillating wave but under effective noise. Okay, let's keep going. So as I said, let's now scatter, and in order to make a scatter plot, here we go, I have to just write scatter. And as I said one more time, like MATLAB is very straightforward. All the functions derived from the same name. And here we go, x and y. Why scatter plot is healthy? Because the only thing he cares after x and y is what? Sizes. Okay, so let's for now x, then plot y. Maybe for the sizes, he just expect us to have a have a digit or a number, so a value. So let's try now 20. Okay, so the default is 36, so we can try 25. No, 25, not 225. And this will make like 25. Here is the size for all my data. So all the data in a scatter plot now will be size 25. Okay, let's see. Here we go. So this is how it does looks like. And as I said, it x-axis from 0 to 3 pi, which is 9.42. So we can see all the circle ends at 9.42. Okay, y-axis like got represented, but with the noise, like it is not make a clear line. There is noise right and left. Okay, but the default 36, so let's make 46 and let's see what we're gonna have. Yeah, much better, much better. Okay, what if I wanna like have different sizes for the data? What should I do to make this happen? Okay, so let's see what we can do with this. Let's make a function called size, or the variable, my bad, called sz, which is size. Same thing, line space. And let's now like specify something like 1 to 100, maybe 200. This is the number, the element, number of elements, and 1 to 100. This time I do mean 1 to 100 is the measure, or like is the size values. So I'm just telling MATLAB right now, I'm gonna like replace 46 with this variable, which is sizes, and the sizes will be 1 to 100 and has 200 evenly spaced point in between, which is gonna like vary all the sizes, maybe from smaller to larger. Let's see and let's try. So okay, so here we go. We start very small, very small, very small, and then start to increase. Biggest here, smallest here. So I can make a variation between my points. Okay, if I wanna like do different sizes. Okay, so let's keep going. What else we can do? C is marker color. Marker color. So marker means like I have the CEO, which is okay. CEO it just reflect for the episode, I believe 3 or 4. So when I see marker symbols, this means the CEO exists, and whether like on conditions that the CEO exists or any symbol, any marker symbol here, I can use three things: marker edge color, marker face color, and marker size, because there is a symbol that's related to marker does exist, which is in our condition now, it's a circle. So let's try yellow, and now it's yellow, but the yellow is very bad. Let's try magenta maybe. No, okay, I don't wanna waste time. You guys can try all the color you guys want. Let's make it blue. Okay, this is decent. Okay, what if also I wanna like have different colors? Okay, what should I do? Okay, same thing or same idea, same concept. So let's also create line space, linearly spaced vector. Okay, let's make a variation, maybe 1 to 10. 1 to 10, this was my x-axis, that's why I choose it. And length of x, which is 200, because I have 200 evenly spaced point, so I want 200 different colors. I can then remove the blue and put C instead, and let's see what we get. We got different colors, different sizes with different colors. It's very powerful, especially if I want to like differentiate between like values. Okay, so another very important thing is the field. Field is just gonna fill the circle. Okay, this marker apparently like marker option, but for a scatter he gives you field regardless. Okay, so if we press field right now, we're gonna see all the circle got filled with the same color. Okay, I wanna also mention that what if I just wanna like skip the sizes and go right away and see, but as we can see here is like there is an order that I have to keep. Like I have to start with x-axis, y-axis, then sizes, then C. And if I did write anything else, MATLAB won't understand it. So if I want to skip something, I will just write double bracket, double empty bracket. And then the MATLAB gonna understand that I set the sizes for the default, which is 36, without writing anything about it. So when I do write this, means I'm skipping that function, and I do want it to be the default. So if we return back again, now it's kind of like the sizes, now it's all the same, the default, which is 36, and it just like now it changes. Okay, so this is how I can do the sizes and the color with field function, and I can just keep going. I can, so as I said, the CO does exist. So here marker symbol, I can choose any marker symbol I do have. Let's try like something like diamond. And does it change all the function to this shape? And MATLAB like make a very great job of this because it expects me to use marker symbol. Can use pentagon, so it's very up to you guys whether it's professionally, unprofessionally. And as I said, the CEO exists, so you guys can use everything: marker edge color, marker face color, everything about marker. All the employer does exist here, so we can use anything we do want. If you want to change the edge, if you want to change the face color, everything is here. Okay, good to go so far. Now we'll move forward with some other idea. What if I want to represent table in my scatter plot? Let's see how we can do this. Representing table in my scatter plot. First of all, how I can read the table in MATLAB. So like I do have a table, but then like how I let MATLAB to read this table. Basically, as I said, MATLAB function goes very phenomenal job in like just making everything easy. So create table from file, just read table. We're gonna treat this file as character vector, which is student data dot CSV. And then like if I press run right now, it's loading, loading, loading. Okay, here we go. So right now this table got created here is not like it just like gives me everything in the table, all the columns or all the rows. Apparently like student ID, student hours. We can understand from this table that he's just talking about correlation between studying hours and exam score and stress level, whether their gender and grade level. So now I did creating the table. So if I return back with a scatter, right now if I want a table, because MATLAB is smart, he saw that I did write in this section table, so he suggests for me putting table first. So table, then the variables, yeah, so table variables, and this is perfect because he create x coordinates with everything inside the table, all the variables inside the column. So student ID, study hours, exam score. If I press here, same concept, student ID, study hours, exam score. So all this data, MATLAB just represented for me because he know like I do want this like variables in my table. So let's see that I want it as a character, vector, not as a string. So let's compare maybe between study hours and exam score. Let's see the correlation. Okay, so apparently, okay, I wanna just real quick also, let's make this, yeah, failed, this is gonna be better. Okay, yeah. Okay. We can see there is a correlation by increasing the studying hours, the score increase. Like we can see here in the x-axis, whoever will study for 8 hours, definitely gonna like get around like 89. Hard work forever pays, but actually like this real data, and this very interesting, yeah. And whoever will study for 2 hours, probably his score is 60. I don't know he passed or not, but yeah, this is a correlation. Okay, let's now ask ourselves, what if I want to compare study hours, okay, but with other thing, like I want to compare one variable with two other variables. What should I do? Okay, so we took this concept little bit last episode, which is the curly brackets. So the curly brackets, it's awesome with any text because it creates cell array, which has different data types that makes it awesome for any text or any characters. Okay, so I can use this, and then I will just instead hero field like let's create other comma, and then I'm gonna like insert like exam hour maybe with the stress level and close parentheses, one or more table array, and let's see what we can get. So I got here that this is the stress level, because if we return back to the chart we can see the stress level, it all exists from 1 to 10. So that's why my function here was also from 1 to 10 for the stress level. And here, this all like, I think this was the exam scores. Okay, but I need to know like the difference between them. So we took this concept now that if I wanna compare one variable with two variables, but right now let's make this clear and like create legend just by putting legend. He gonna, yes, okay, this now makes sense. The stress level is the orange, but the blue one is exam scores without anything. Okay, let's try this now. So what if I wanna like write location, and now for the location, like location of the legend, let's create best. Here we go. So MATLAB automatically he puts the legend in the best location he sees, which is here, because like here he was like kind of covers some data. So I wanna all my data to be clear. In the same time, I want the legend to be in place that doesn't affect all my data. So just MATLAB like creates this for me, which is awesome. Okay, so far so good. let's move forward. Right now, we're gonna explain another concept, which is creating a stem plot. Okay, professionally the professional name is called discrete, okay, sequence data. Okay, but the unprofessional names that I'm gonna give it, it's just the lollipop graph. This is funny, but why it's lollipop? Because it does looks like it. Okay, and discrete sequence because stem plot is just like very very important for different aspects and different usages, whether in statics, calculus, anything with number, stem will be like very very great tool to use, even in like plotting 3D, and we're gonna explain this as we go further. Okay, so let's start. Let's see what we can do here. So let's create figure figure 1, and I think f should be small. All the mistakes come from very very tiny like small instead of capital. All this stuff can make an error, and like this error might spend long time until you actually like discover where is the error came from. Okay, so line space from 0 to pi. 2 pi, by the way, it's just like 6.28 and then 50. Okay, we want to do one more thing, comma. Okay, what this means? So I know that you guys now are familiar, starting from 0 to 2 pi and has 50 evenly spaced vector. Okay, you guys want to say, oh, we already know this, but what this comma mean? It was in the very very first episode I did explain this. This is transpose. Transpose, quick recap, it's just like switching the rows with column. So right now if I press run, okay, apparently there is nothing like here, but like let's clear everything in the workspace and let's press run again. So right now I do have it won't appear here, but the x now is column vector. Like instead of row, you're gonna give me like from 0 to 50 rows, but this as a column vector, so I can combine it for the y axis, especially with the stem plot. So as I said, transpose or this comma, it just turn everything from rows to column and from columns to row. But right now, because I'm from x axis, so I'm gonna turn it from rows to column. So right now x, another comment here, x is a column vector, and this is very important as we are going forward because we're gonna combine it with y axis. Okay, so let's create y equal, let's open bracket cosine x comma 0.5 multiplied by sine x. This is very interesting, right? Okay, so what's going on? Very basic stuff, but this also was in episode 1. Those brackets, this is a matrix, correct? Okay, so this comma, now like cosine x, first column, 0.5 multiplied by sine x is another column. We were saying in the first episode that the comma is creating a new column, but semicolon is creating a new row. This like the semicolon, this, but if it was between the brackets. But now just comma. So now I do expect 2 rows, or y gives me 2 rows. X, now I can say cosine x in a matrix because I change it with the transpose to column vector. So right now when I'm treated as a y-axis, now it can combine together because this is column vector. But it's gonna be messed up if without the transpose. Okay, so I'm telling MATLAB now, create a matrix with 2 columns, which is matrix y with 2 columns. Okay, so column 1 it just is just the cosine x full amplitude cosine, while column spelling column 2 it just have half amplitude sine. So MATLAB will treat each one as a single vector. So right now when we actually creating the stem plot, we're gonna have two shapes, or like as I said, MATLAB will treat each one of them as a single vector. So we're gonna have two like shapes, and we're gonna see this. Okay. Now, so here is the deal. We wanna create a stem plot function. This is a stem. I don't think like there is no surprise by now. Okay, let's see what we can get now. Okay, as I said, MATLAB gonna treat each one of them as a different single vector. Okay, and he gives like differentiate between both with different colors. And as I said, now like it's between 0 and 50 with x-axis, and this because like it's from here it was like 50 points. But what if I remove the transpose and I press run? Let's see what will happen. Totally different thing. Totally different thing. Okay, so now like x-axis basically right now it's row vector because I didn't put the transpose. So when it gets combined with the y-axis, it got messed up, and there is something like missing here. And even MATLAB like he doesn't give an error, but he does give an error in the actual figure. That's why like transpose or switching between row vector and column vector will go a long way. Okay, so far so good. Okay, let's make it like more interesting. So let's edit some stuff. Okay, so right now I just maybe like let's try like field. I think you guys already know what's field mean, or you guys can expect. Here we go. Like it's just gonna like make the marker different. Okay, and as I said, over here we do have what circle, CEO, which is marker symbol, right? So now I can make marker, and I can choose whatever I do want. Let's see. Okay, I don't want to just like waste time. I can like pentagram. Okay, I can also like change line style. He gave me an option, maybe this one, and now it's like this. But okay, let's return back to the marker and let's make it circle. I think it's gonna be better. Yeah. Okay, here we go. Okay, so I just like running a little bit fast in the things that you guys already know, but let's kind of explain something you guys might be new in this, which is clipping. Okay, and on and off. So what does this mean? So what's a clipping like on? Might not be obvious here, but it's very important like function to know about. So clipping, it just control whether the object gets cut off at the axis limits. What this means, let's say I have a lot of data and the x-axis is very limited. So there is some data that I do have, but it's just getting cut, or like it's just hidden in this like I do have data that continues but just hidden because the x-axis ends at 50. So this is clipping. Clipping that might control this, whether like I want my data to be hidden or not. As we find here, there is on and off, okay? Right now, because the x-axis does like fit all my data, so I don't think it's gonna be any different. But overall, please, you guys, as I'm always saying, please take note as we go, because this is how you guys will learn, okay, by trying everything on MATLAB. So just on if the object goes outside the axis, which is like hidden, like data is hidden, okay, but clamping off just means the whole object is visible even if it's outside the axis. The whole object is visible. So I'm pretty sure, okay, all of us would be wanna use off to make all his data is visible, unless he wanna like just hide some data. Right now, like we can see, like there is a space between like 0 and 1, and we can see this is the last like data that we do have, because if there is other data, you're gonna make a space for us. So this pretty much clamping is very like important to have this like in your bank knowledge, MATLAB bank knowledge. And okay, let's also like create some like legend. If we create legend only, you're gonna give me like data 1, data 2, because there is no names for the legend. I can just like label one, maybe um, mm, 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 maybe cosine x. Okay, second label, like MATLAB just start understanding me, and I can here like make sine x, but let's multiply it by 0.5 right now. Okay, the blue one is cosine x, 0.5 sine x is the orange one, and I can say something like location. Now like MATLAB understands that I finished my labels and I wanna now like options, which is location, and then let's do the same thing as we did, best, location, best. Here we go. He gave me in a position that won't cover all my data. That's very powerful. Okay, and let's move forward. Before moving forward, I want to introduce one more thing. I want to like say I want to control my axis. So there is also very important rule in any plot which is called axis, and then like let's introduce this, which is axis style, and he can give me variety of style. Okay, here we go. So I can just choose different stuff, okay, of how like my axis want. Let's introduce today, just for today, padded. So what's a padded, or what does do actually? So just if you use this, MATLAB will create extra margin or space, so the entire data would fit. Let's copy this here and let's delete this. And this very powerful if you have long data that has to be represented. So right now, if we press run, you guys can see there is extra margin for some few data, or for the entire data to be like fit, or it could be seen. So this is just the padded one, but yeah, there is like normal is normal, of course. Tight, you guys can try, it's all like different stuff. Tight, it makes all your data is tight. If you like try something square, it's gonna make the entire axis a square. And axis because he's talking about x and y axis, so that's why it's called axis. And then you can like customize as you want. So right now let's just start with padded. Okay, this is the extra margin that it does create. Moving forward, time right now to create a 3D stem plot. Okay, it's not hard at all. 3D abbreviation, of course, for 3 dimension, which means x-axis, y-axis, z-axis. Okay, you can create any 3D in the world if you do have digit 3. So in order for us to create it, we have to create three axes, x, y, and z. Okay, let's try. Let's begin first with x-axis. Okay, same thing. Line, space, 0 and 2. Start with 0, end with 2. If I just ended right here, the default will be 100 evenly spaced between 0 and 2, and this is gonna be for the y-axis. Okay, let's now create, my bad, this will be for the x-axis. Let's now create the y-axis. Let's make it something like x dot power 3. Okay, I wanna stop here and explain a little bit. What does this mean? Okay, so this looks familiar, right? This is kind of like element-wise multiplication. Yes, and we did explain this also in episode 1. But instead of element-wise multiplication, this element-wise exponentiation, element-wise exponentiation. So I'm just telling MATLAB right now, please create a new array called y, okay, that has element-wise exponentiation, and just like give us a curved shape in xy plane. Okay, so what's mean by like that thing? Dot element-wise exponentiation, element-wise exponentiation. Okay, so what's this means? Element-wise. So it's called element-wise, as I said again, like quick recap, because it's gonna choose the position 1 from the x, and then it's gonna make this function, which is x power 3, but it will be in the position 1 in y. That's why it's wise, because it does choose the position 1 to position 1 in both variables, position 2, both variables. So if I do have 2 in the position 1, okay, but this in the variable x, it's gonna be 8 in position 1 in variable y, because it does make 2 power 3, and so on. That's why it's called element-wise exponentiation. Okay, this for y axis. Okay, now we do miss the third dimension for a 3D, which is z axis. Let's make exponent, this time x. Let's make a similar thing, but right now we're gonna make element-wise multiplication with cosine y. Okay, should I stop here? I'll stop just for a little bit. Okay, so exponent x, it will just give me an increasing curve because it's exponent. Cosine y, create wave-like oscillation. Okay, this now it's element-wise multiplication between them. And as I said, why it's called element-wise, like same concept as the power 3, but now it's multiplication between exponent x and now cosine y, which is like wave-like oscillation. So z now expected to will go up and down, and the peak will grow larger as x increases, because like here x, so as x will increase, it will increase y, so it will increase z. Just direct relationship, everything gonna affect each other. Okay, so far so good. Okay, so right now, time for plotting. Stem 3, plot, plot 3D discrete sequence data. So plot 3D. I love the description, so this is what we're gonna use. 3D, so stem 3 as a 3D. Okay, X, Y, Z. So X, here we go. Y and Z. Okay, and then let's see what we'll get. We got the 3D shape in front of us, the first 3D in the MATLAB mentor, the first 3D plot in the MATLAB mentor. Okay, so this is how it does looks like. We can just like try to explain some stuff. Here's the x-axis from 0 to 2. Y-axis, as I said, it's element-wise exponentiation, correct? So here is 2, 8, 1.5, 1.5 over 3 is 6, and so on as we go. Okay, but for the ranges, for the ranges in between, not exactly like this, but this from 0 to 2, because this is the ranges, and it's going to be reflect in the y-axis, and this is the z-axis. So x-axis, y-axis, z-axis going up, and this is the 3-dimension 3D. But let's make some like modifications. I will go like fast because you guys already know all of this stuff, like x labels. I mean, they are kind like fundamentals. Okay, so let's make like x-axis, line, space, and maybe font size to be 15. Y label, oops. Okay, Y label. Let's make like x power 3. Same thing, font size 15. The new thing, right now I can do Z label, and he also will accept it. Okay, and let's write here element. I'm always forgetting this E. Element wise multiplication. Font size also 15. And let's see what we'll get. Okay, here we go. Sounds good. Looks good, right? Let's make just a quick title. Stem 3D plot. Font size 16. Stem 3D plot. Line space for x-axis, x power 3 for the y-axis. Okay, element-wise multiplication from z-axis. Okay, this is the title, and this is the 3D plot. As we can see, when we did all the labels for all the axes, he gave us x label in the position of x-axis, y label in the position of y-axis, and so on with the z-axis. So finally, now we reach to our time for the mini assignment for tonight. So our today's mini assignment will be 3 things. First of all, practice creating advanced scatter plots with variable size and color. Second thing, visualize data using scatter plot. Please feel free to be creative, feel free to try different things, and just try to discover. MATLAB helps you. Also, like review this several times. Okay. Third thing, understand and use stem and stem 3 plots. Stem for regular stem like 2D stem plots, and of course stem 3 for the 3D plot. Understand and use stem and stem 3 plots. Finally, apply plotting customization. And here I do mean like maybe legends, labels, and marker styles. I do believe whether like in scatter today or even in STEM, there was a lot of marker styles that you guys like very important. Like oh, we already covered this before, but all this stuff like that's why I do emphasize on watching all the rest of the episodes because and emphasize also on note taking because we are building a knowledge step by step by step by step. So in the next episodes when we are doing harder stuff or when we are going next level, you guys will have the base and understanding of going through different stuff. So now we have reached to the end of our episode. Make sure that you did right and tried everything by your own. Feel free to do the mini assignment and leave comments for any questions. So as always, programming always about practice and practice makes permanent. Thank you all and see you all next episode.